Hello everyone. So today is lab 2 and it is about running web apps on Docker, and in this lab you'll learn about what are image layers, how to Dockerize a node application, what are the networking in Docker, and what are volumes in Docker. So before going to lab 2, I'll just first revise the lab 1. So in the lab 1 we learned about what is Docker, Docker basics, how to pull an image from Docker, how to run a container, and at the end we Dockerize a Python application, which is Flask application. So to learn more about lab, you can refer the lab 1 video posted on Brightspace. So these are the important commands which you need to remember, and if you do, then like there are only few, so if you remember this, then it will be like helpful for you. So first is Docker pull, and after pull you write the name of the image. So let's say this is Docker Hub, so like GitHub, this is Docker Hub, and it has like in the GitHub we store repo, in Docker Hub we store images. So that's so like these are the list of images. So let's say I want to pull this image. So if I write docker pull alpine, then it will pull that image on my machine. Or let's say I want to run MySQL on my machine, but I don't want to install it. So I can do it with using Docker. I can just write docker pull MySQL and then run the docker run command. So it will be like running MySQL on my machine. I don't need to install it like anywhere. So that's the power of Docker. And why we use Docker? Anyone?
Because when we develop any software or application, then it might be the thing that it works on one laptop and doesn't work on other laptop because of versions and all that.
Yeah. So when we run an application in Docker, we pack it with a base OS, which could be like Linux, simple Linux OS like Alpine or like Ubuntu or any OS. We also pack it with the libraries which are required for our application. For example, if we are running a Python app, then we might need this list of requirements. So we pack those things in the container, and at last we also pack the source code. So now the container has source code, libraries, and base OS, right? So now it will be able to run on any environment because we provided it these things. So like if I run it on my machine, Mac or Windows or Linux or any Linux server, it will be running fine if it's running on my machine. So that's the main reason of running Docker. You want like portability of your application. You don't want any errors, and if you have multiple version of your application, you can just create 2 containers with different versions. So it's very easy, right? So that's why we use Docker. Okay, so moving to next part is Dockerize the application. So what is called Dockerizing the application? So like if I run this application on my machine, just my machine, I'm just running the application. But Dockerizing application is like I'm running this machine on Docker containers. So this is called Dockerizing the like application. So anyone know Flask? Okay, so it is like a framework in Python which is used to create web applications or services. So like it is pretty simple. You just import it, you initialize the instance of Flask, and these are called routes. So when we write, for example, localhost, let's say it is running on 5001. So if I write this, then this is called base route. If I write API, then this is called API route. It is just an API. So if I write one more thing, route API, I'm writing a function and returning a string. Okay, so this is like an API in Flask. So basically this is a simple Flask project, nothing else. Now in Python, we have requirement.txt, which are like list of requirements which are used in the application. So it is like basic Python thing. Now the Docker file. So what is Docker file? So Docker file is used to create an image, Docker image, and it has set of instructions. So we provide these set of instruction and it creates a Docker image. So the first is from Python 3.8 Slimbuster. So the first line which you write in Docker image is like the base path from where you want to pull, like which base image you want to use in your containers, because we need an operating system at the end, right? So this is where we like get the base image. So I can write Ubuntu and then install Python in it, or I can just use Python image which is already there in Docker Hub. So you can use anything, but it's easier to just like write one line, right? Then what is work directory? So the path inside the container where everything will be stored related to our application. So this is work directory. I'm going a bit fast for this, but I'll explain this again in the node application, which will cover in this lab. Now copy is like copy a file from my machine to inside the container. So this is copy. Run is like when you create an container, if you want to run multiple commands, then you write run and then command name. Again, copy is like when I write copy ... which means copy everything from the current directory inside my container. So everything which is present in this current directory will be stored inside this. So why we need that? So the first thing is we have a base image, right? Now we want the libraries which are required in our application. So I copied the requirement.txt file and install the requirements. So now I have libraries and OS, but what else I need? Source code which I need to run, right? So next part is this. So this copies the source code inside the container, and expose is like when you run a container, you need to expose the port on which you are running the container. So my application is running on 5001, so I'm exposing the 5001 port. And the last command is cmd command is executed when the container is created at the end. So when everything else is done, I'll just write this command to run the Flask application on port 5001. So this is like list of instruction I'm giving to create an image. So I'll just now fire the command to create the image. So docker build -t is for tag name. What is the name you want to give to that image? So I'll write Python Flask app, and dot is like, I'll just copy this. Okay. So if I write ls, then you see there are 3 files in the current directory: Docker file, app, and requirements. So when I run this command and when I write dot, it means that this Docker file is present in this current directory. So if it was somewhere else, then I could have write slash files slash docker slash something xyz and slash. So I'll give a absolute path of where I have stored this Docker file, but it is in this folder itself. That's why I'm writing dot and build. So when I run this command, then it will like execute the instruction which I have given to it. So for example, 1 of 5 is it is pulling the Python 3.8 in my machine. Second is it is creating a working directory, copy the requirements, install the requirements, copy the files, and exporting the image. So if I write docker images, then there is this image which I have just created. So this is Docker image. So now I have created an image, but when you want to run your application, you run on a container. So when you run a container, you use the instruction provided in the image. So for example, if I write docker run -d, I'll skip this right now. So when I write docker run, and then you have to mention a port here, -p, which is for publish, and this I have covered like in lab 1. So for those who have not seen it, you can like revisit the lab 1. So it is just, what it is doing is, it is mapping port 5001 of my machine to port 5001 of Docker. So this is what it is doing. It is mapping it, and then I have to specify the image, and if I write this, then it has created a container and it has used the image which I have used, and now it is running my application. So if I go to browser and write localhost 5001, it will give me this. And if I write /API, then this is an API which we have just created. So basically now my application is running on a container, not on my machine. Like, it is running on a container. So any doubt in this? Yeah.
Can you go to the Docker file?
Yeah.
So the last command we have written on line 13. So this is the command that is used to run the Python application in your local machine.
Yes, and this command is executed when you are running a container. So when you create an image, it is just a blueprint, and when you create a container, after that it will fire this command. So a image is like just a blueprint with the set of these instruction, and when you run a container, it is actually then your application will be running. Before that there is nothing, just a blueprint of container like that. So the CMD, whatever you write in CMD, will be executed when you run the container.
CMD is basically used to run the application. For example, let's say now we usually have one command to run the application. Either it will be mode of run.
Yeah.
Let's say what there are series of commands to follow.
So you all only need one command to run an application, right? But if you have series of command, then you can like write run and then command 1, and then again run command 2. So you write these commands, and then at the end you write CMD, because this is the command which will be going to run at the end when you create a container. So like, I'll show this thing again, docker build -t demo and dot. So I have built the image again. Okay, I'll have to delete the image to show you the whole step. Docker build -t python app dot. So here, if you see, all the commands which we have mentioned in the Docker file are there, except for this CMD command. Here we have from base image work directory, copy, run, and copy again. So almost all the commands are there. Expose is not there because it is also run at the runtime of container. But you see, like when we create an image, the CMD command won't be running. It will be only running after when you run the docker run command. So like, that is the main thing you need to remember.
Okay, in the Python, the version that you use, the 3.8 Spin Buster, did you select it based on the OS version that would support for this?
So like on Docker Hub, if I go to Docker Hub and go to Python, there are this many version like images available. So I chose the Slim Buster or you can use Alpine version. So like if I use Docker base Python image, then it will be of size 900 MB. And if I use Alpine or Slimbuster, then it will be of 80 MB or 70 MB. So the difference is what are the things you need in the base image. So to just simply run a simple Flask application, I don't need many things. So I'm using the smallest image available for Python. And like if you want to run some intensive task like data science, something like with NumPy machine learning, then you might need to use a bigger image. So you use the image, select the image based on your use case.
Can I use the same image even for the Windows? For example,
Yeah, same, it works.
it's
Yeah.
independent of the
Yeah.
image.
So that's why we use Docker, because we want the portability of your application. So yeah. Any doubt?
So the CMD command that we run, why is it command separate? If I write in one simple string with spaces, is that fine?
I think it would work, but when you write arguments, then it is good to write in comma separate. It improves the readability. So yeah. Any doubt?
In CMD command, like all are mandatory fields, or like, because I have seen like only one or two fields, like Python 3 and some like
Just app name.
Yeah,
Yeah.
two parameters was there.
So if I write just CMD Python 3 app.py, then also it will work. But I want to specify the port, so by default it runs on port 5000
Okay.
whenever you run a Flask application. So I want to specify the port, and I don't want to run it on local host inside the container. I want to run it on my like 0.0.0.0, not the local host. That's why I mentioned this. So like it's up to you, whatever your command is to run your application.
Here, let's say if I do, let's say 5032, and down also I get 5032. So when I'm running my Docker run command, then it will be 5001:5032.
Which here or
When I'm running the container.
okay, so like this one,
Yeah.
5001, and this side you want to run on 5000. Okay.
So local 5001 maps to 5032 of container.
Yeah, we'll just run this. So on the left side you write the port of your machine, on the right side you write the port of your container. So this should be the same, but this is 5032. So if I write it again, Docker images, I just changed the name of image. It's Python app. Okay. Also one more thing. You see when I run this command, my console is stuck because, and if I do Control C, it stops the container. So what if I want to keep it running in the background? So when you want to do that, you write -d, which is detach mode. So like if I do this, then my console is free now and the container is running in the background. So I have run this app on 5032 port, and I'll also run this in 5033, let's say. So two applications are now running, and if I go to browser, 5032 and then 5033. So there are multiple containers running the same application on different ports, because you can't run multiple applications on same port. So any doubt? Okay. So like that was the part of lab 1. So now we'll start lab 2. So first thing is image layers. So what are image layers? So any instruction which we write on in the Docker file is a layer. So when I write from base image environment variable something, run some command, expose some port and CMD, so each line is a layer in the Docker file, like Docker image. So I'll just explain this in more depth. So let's say, so this is a image. Let's say it is the base image is Ubuntu. So when we write Docker in like from, so I have written this Ubuntu, like from Ubuntu. Then I'm installing Apache. So it is Apache server which is used to like when you deploy a web server, then you put Apache server on top of it to add load balancing or to scale it. So I have installed Apache. So let's say I'm running some commands, sudo apt-get install Apache, something like that. So let's say I have done that, and then I'm providing source code of my application 1. So let's say it is microservice, and let's say it is of Amazon. So the app 1 is like getting the products, and app 2 is the payment, something like that. So when I create app 1, if I have nothing there in my local machine, then it will pull it from Docker Hub. But now I am creating application 2. Now Docker will check if I have already these things in my local or not. And if yes, I do, then it will reuse that and just create an image with app 2. But behind the scene, it is using the layers which is already present in my like Docker, local Docker instance. So that way it saves your like storage in your local machine. So it is reusing the things which is already there, and like the different thing is what differs the images, two images. So when I run container 2, it will be running this, and container 1 will be running this. So any doubt? Yeah. Yeah, so I'll just use the example of Python here. I'll remove this one. So let's say I want to Dockerize a Flask application. One is for handling the products, and second is for handling the payment. So let's say I'm running Python 3.8 Slimbuster, right? So when I create first image of app 1, then let's say I don't have any Python image on my machine present. So Docker will pull the image from Docker Hub. But next time when I want to create app 2, which has completely different source code from app 1, they are not connected. But one thing is common between them is the base image. So Docker will use the image which is present in my machine. It won't pull from Docker Hub. So it will be like faster because it is already there on your machine, right? And it will save the storage, because if you have same image twice, then it will take space. For example, Node has like 1.2 GB of base image. So if you have multiple Node images, then your machine might get full, right? So this is like smart way of Docker. So these are the layers. Any doubt? Okay, so now we'll Dockerize the Node application. Oh. It might have gone deleted. Okay. So let's create a folder Express app, and I'll go inside the folder npm init. So when we write npm init, then it creates a packet.json file. Index.js. I'll copy this base Node.js program. It has one route returning hello world, and it is running on port 3000. Next is npm install to install the base Express, and I'll create one Docker file. So this will be the Docker file for the Node.js app. So again, base is Node, and there are different version of like different images of same like environment. So for example, Python, we have so many like in Node we also have many images, but when you use Alpine, then it is the smallest image of Node. So that's why we use Alpine to like save the space, and we don't need big image of Node, just the small one to make it work. Next is working directory. So like remember this working directory src app. So in the Python application we also mentioned this src app. So what is it? So let's write docker ps command, which gives list of running containers. So now let's assume that each container are like Linux machine OS. So I'm going inside the container now from my machine. So to do that, you write docker exec -it. -I is for interactive and T is for this terminal. So open this in my terminal. Then name of the image or name of the container. So this is the container ID. So you don't need to write whole container ID, just write the first 3 characters. So cd1, this one, and which you can write bash or sh, whatever you want. So if I write bash, then it will open a bash terminal, and now I'm inside the container. So you see this has redirected me to user src app folder, which is, I'll open it again. So in the Docker file we wrote working directory as user src app. So I'm inside this folder, and if I write ls, then it will give me all the files which are present in the user src app folder, which is what we did. We copied this recommend.txt into this folder, and then everything from my local directory we paste it into this working directory. So whatever I had, this docker ignore app, docker file, and recommend.txt, I have these things here. So you get the gist of it, right? We are running a container. Right now I'm inside the container. It is kind of like a Linux machine, small Linux machine, and whatever command you can fire on Linux, you can fire here. So if I write cd ... and if I write, so I'm going to base path, and if I write ls, then if you know about working in Linux, then you'll know like this is the same thing which is there in Linux. Like if you go to base path and run the ls command, you will see this folder structure. So like it is in the Linux, it is like this structure is used user src app to store your application. That's why you follow this convention. So again here we are writing this. I can write user src app or just src app, whatever you want. Now copy packet.json because it has all the requirements present. So just like Python has recommend.txt, it has packet.json. And next is you do pip install in Python, you do npm install in Node. Then copy my source code inside the container, so like this. And the last is cmd. So in Python we write python 3 run flask app. Here we write node and then file name. So like basically everything is same. It's depend on what language you are using. So yeah, and I'll just exit this. Okay, so I'm inside this express app. If I write docker build -t express app dot, then I don't have any base image of Node in my machine, so it is pulling from Docker Hub, and it has, if I write docker images, then we have now two images. One is Python app, which we ran before, and now Express app. So the image is created, the size is also here. So if I want to run this, then docker run -d for detached mode, -p is for port mapping, 3000:3000. I'm running on 3000 port of my machine, connecting it to that, and then name of the image, and it has written me a container ID. So if I write docker ps, which gives all the, so it is not running here, so there should be some error. Cannot find Express. So there is some issue. Okay. So I have not installed Express in my Node application. So if I run npm install Express, so now it has added dependency. Previously it didn't, so that's why it gave error. So now I have dependency. So the image building got failed. So now I have added dependency. So now I'll have to rebuild the image again to update it. So clear. Now docker build -t express app and dot. So if I give same name here, then it will just update that image. So here if you can see, like the second time I didn't pull the image from Docker Hub, it took one from my local machine. So that's the Docker layers which we talked about previously. So if I write again docker run -p 3000 -d express app, so now it is running the express app, and if I go to localhost 3000, then hello world is written. So any doubt in this?
So now we need node install express, right? So it's installed in the local machine, right?
So when we write npm install express, then it installs in my local machine, right? But it also add like express in the dependencies, right? So when we like execute the npm install command inside the container, then it will install the express inside the container also. That's why in the first time it didn't find express, because there was no express in the package.json file.
Instead of installing, we just write the express thing in the requirements. That
This one?
just-
Yeah.
And
Yeah, we can do that.
will, only do in the container only, right?
Yeah.
Okay.
This is just for like version. I don't know the
Yeah,
version,
yeah,
so
yeah. So that's why
yeah.
we
Hmm. So whenever you are using Python or Node, if you are adding new dependencies in the local, then always remember to rebuild the image again, right? And there is one more thing. So I'm in this base folder, right? So if I write docker ignore, so you know git ignore, right? So docker ignore is like things you want to ignore while copying inside the container. So we have this copy ... command. So it copies everything in this folder to the inside the container, right? But I don't want to copy the node modules because it's useless for the container, because it is going to install the npm install, right? And it could be very big if you have so many requirements. So that's why if you use docker ignore and give the list of files here, then it won't copy it in the container. So again, good practice is to use docker ignore. For Python, you can write venv, because it's not useful in the container. So yeah, and in Node, you write node modules. So this is just for ignoring the copy. So any doubt? Okay. So next part is, which is really important part in Docker, is Docker networking. So a container or like Docker image is just like a virtual machine, but it is very small, but it has a file system, which we just saw when we went inside the container. So it has a file system and it also has a networking. So when you install Docker, you have by default 3 networks. First is bridge, second is host, and third is null. So what null is, like if you have a container, you don't want to be connected to anything, any network, then you use null. Host is like the container is using your host machine networking directly, which you might need in case of socket or something like that. So I have not used it anywhere as of now, but there is a use case of host network where you need a container to be connected to your host machine. And the third is bridge, which is by default network, which is connected, like whenever you create a container, it is connected to this bridge network, which is by default. So when we go to CLI, if I write docker network help, then it will give me the list of commands which can be used for Docker networking. So the help command is very useful in Docker. So it has given me like this command. So if I write docker network ls, then it will give me list of all the networks which are present on my machine. Currently there are 4. I'll just delete this one. So to remove a network, you just write docker network rm mynet. So I have 3 default networks. Now we have 3 containers running, right? And they should be connected to the bridge network by default. So if I write docker network inspect bridge and this, then we are like inspecting the bridge network, and we have 3 containers, this one, this, and this, and these are the name of the containers. So if I write docker ps, so this are the name of containers and they are connected to the bridge network by default. So any container you create, it will be connected to bridge. So for assignment 1, this concept will be useful for you. So let's say I have 2 applications. One is 2 microservice, for example. One is backend service XYZ anything, which is running Python. It is using MongoDB for database and Redis for caching. So there is one scenario where I have this microservice, and let's say I have one more microservice for XYZ service, and it is using Node, Elasticsearch, and Postgres database, right? 2 microservices. So they don't depend on each other. So the best practice is to create different networks for these 2 services so that any other container can't interfere this service. So when you use microservice architecture and you have different services, then it is best practice to use like different networks for each services. So what you can do is like create 3 containers and connect them in a separate network. Then again 3 containers, connect them in a separate network. So I'll show you hands-on, but this is the concept behind it. So any doubt in this? Yes. Yeah. So now let's do the hands-on. So I'm writing docker network help again. So these are the commands which are there in Docker network. So let's write docker network create for creating a network. So create, and I'll write Python node, the name of network, Python node. So Okay, I wrote connect instead of create Python node. Okay, so I created a network with the name of Python node. So if I write docker network ls, then there is a network here. And if I write docker network inspect Python node, then there is no container right now connected to this network. So now if I write docker ps, then we have these 3 containers running, right? So now I want to connect the new container, new network which I have created. For example, I'll write here Python node. So this network I just created. Now I want to connect this Python container which I'm already running in this network. So how do I do it? So docker network connect, then name of the network which is Python node, and then name of the container which you want to connect. So for example, I want to connect this Angry Mendel. So I'll write the name of the container, and if I press enter, then if I write docker network inspect Python node and this, then now this container is connected to like this Python container is like connected to my network. So now I'll do one more thing. Like feel free to interrupt me if you have any confusion. So next is I'm running a Nginx server. Do you know Nginx server? So just like Apache, it is Nginx is like same used as a web server. So when you deploy your React app on production, then you don't run npm run dev or npm run preview. You run Nginx server and run your application on top of it, so that it has load balancing and many more features like that. So it is just a web server. So I'm running docker run -p. So Nginx is by default running on port 80. So I'm running like port 80. -d is for detach, and the name is Nginx. So Nginx is not on my local machine. So if I write enter, it will pull from Docker Hub. Okay, so now it is running. So if I write docker ps, then I'm running a new container with the name of interest. It is running on port 80. So if I go to browser and write not 8080 but port 80, it is giving me welcome to Nginx, which is Nginx running on my Docker container, right? So now I'll add that Nginx server into the new network which we just created. So Python node, and this is the name of the Nginx server. So enter. So now if I do docker network inspect Python node, so there are 2 containers now inside my like Nginx. So not Nginx, the network, we have 2 containers, right? So when you have separate yeah,
Here we have pulled the Nginx from Docker. Then we need to stop it when we done using it. Or
yeah, if you don't need it, then you can stop it like that.
This is a command.
Yeah,
We need to do manually.
docker container stop and then name of ID, container ID, that is. Yeah. So now I have Python node network and 2 containers are connected to this, right? So we also have a node container which is running on port 3000, right? So now this container won't be able to communicate with these 2 because they are on separate networks. The node is in the bridge network and these 2 containers are on Python node network. So like they are basically isolated from each other. So you know, like now you know the use case of it. When you have similar services, you create a network and then you connect them. If you have different service, you create another network and then connect them. So any doubt here? Yeah.
Then all the three are on the bridge network, they will still have a different IP address.
Yes.
Then what is the
But they are in the same network. So you use, like, for example, if you need communication of these three in XYZ service, then you have to put it in the same network. If you put it in different network, then they won't be able to communicate with each other because they are basically in different networks.
If we expose ports,
Still, we expose the port inside the network, not like inter network. So whenever you expose the port, it is exposing the port for this network, not the bridge. So then also you won't be able to communicate with.
like local host and
Yeah.
okay, okay. So in assignment they have said that we are supposed to isolate those things.
Yeah. So you have to create a network
Yeah.
and then connect the containers to that network.
Okay. And IP address would be dynamically assigned, right?
I'll like show you how to use that in like this. So any doubt? This concept is used in your assignments. So like you need to create a network and then two containers in it, and you should be able to communicate with each other. So this will be used in assignments. So any doubt here so far?
if there are 2 or 3 services within the bridge network, they can communicate.
Yeah. So like by default everything is bridge, so they'll be able to communicate with like each other if they are in the same network. Cool. So now, okay, so if I write docker ps, then this was the one, right, which we added angry Mendes. Okay, so now I'm going inside this container, docker exec -it, then like id of the container 1c7 and bash. So I'm inside the Python container, this one. Now I should be able to communicate with this one, right, because they're in the same network. So let's try that. So I'm just installing curl in this container. So do you know curl?
We use it in Postman to
Yeah, so just like Postman, if you use CLI, then you use curl to like fire any request to any server. So I've installed curl in this Python app. So now how to communicate inside, like with each other in the same network. So when you write curl, then what was the name of Nginx? It is interesting pain. Okay, so if I write curl in this and 80, then okay, it is giving me error. Let's try this. Docker network inspect Python node. So like when you have container, then they have their IP address, right? So you can find the IP address from here. So this container has this IP address, and this Python one has this IP address. So I can use IP address to communicate with them. So instead of the name, I can write curl. Let's say I have curl. Okay, so curl. So when I did curl, it returned me this HTML, which is this HTML. So now I have called a curl request from this to this. So they are able to communicate with each other because they are in the same network. But if I write, let's say, docker network bridge inspect bridge, so this one is the IP address for any other server, and if I write curl so this is the IP address express app, so curl 3000, then it won't be able to communicate with them because they are not in the same network. So this thing is possible right now, but this thing is not possible because they are in the different networks. So another thing is like, what if I don't know the IP address of Nginx server? How do I do it? Yeah.
The command is not from this page.
Oh, sorry. 172. So it is giving me hello world, which is not sure why, but when we went to the Docker inspect of bridge, then all the 4 containers are in the bridge network. So first we'll need to disconnect it from bridge. So I'll disconnect the Docker networks, disconnect bridge, that, and this one, Docker network disconnect so if I write Docker network inspect ls, so now there are 2 containers, one is this and this, which are this Python and this node. So right now in the bridge network there are 2 containers, the node one and a different Python container, and inside Python node there are 2 containers, one is this Nginx and other is Python one. So if I write again this command, then it won't like be able to communicate with it because they are not in the same network. So you got the point?
One container can be part of another.
Yeah. I didn't knew that, but yeah, they could, I guess. So now this will return 404 error because they can't communicate with each other. So next thing is curl. It should work, not sure why it didn't. But like it should work, not sure why I need to check, but
Shows that image might not be close by.
no, so like it doesn't matter with the image. So like these are 4 contain. I'll just delete these 2.
But sometime it happens.
Yeah, so like this is the
Should use alpha
it is happening right now, but when you use Docker Compose or like, not sure why it is happening now, but it worked earlier. So in short, what so like Docker has inbuilt DNS in it, so you can call any service with the name of the container. So in your assignment, if you have 2 containers, let's say you have written container 1 and container 2, the name of the containers. So based on your assignment, you need to call container 2 from container 1, right? So to do that, you can use this name as the IP address, and you can write http:/:container2 port on which you are running on, for example 5001, and the API name. So you can call this API from container 1 and you'll be able to communicate with each other. So always use the name of the container as like IP address, and Docker will handle behind the scene because it has inbuilt DNS.
But when we create 2 containers, then why
Default,
being
yeah.
bridge?
Yes, but the point is, so like you are not going to use Docker command to like create the containers. You are going to use Docker compose file, right? So when you use Docker compose file, then it by default creates a separate network for you. So the containers which you create won't be in the bridge, but they will be inside a new network which is created by Docker compose file.
So we need to specify network parameters, right?
So it actually does everything for you, so you don't need to do anything. It like makes your work easy, I guess, for assignment, because you can just directly do this when you use a Docker compose up, because it will create a network. It will put those two containers in that network. So now you have two containers in the same network. Now you can just call each other using the container name. So all you have to do is like write a container name inside a Docker file and not keep it random.
And we should not be exposing the second container, right?
Yeah, for the outside, right? Yes. Any doubt?
Apart from curl, are there any other ways to communicate with the containers?
You can also NS lookup will work, right?
NS lookup is for DNS. Yeah, I think curl is
Ping.
yeah, ping you can do, telnet you can do. Based on which port is available, you can do the things. So any doubt in this? So like that's what we did right now. We created two containers and there is one node container, so they are all in the same, so they should be able to communicate with each other, which they can. The container name is not working for curl as of now, but it will work. So this is the Docker network part. So if you have no doubts, we can move to next part is Docker volume. So any doubts in network? Okay. So next is Docker volume. Also, I have written this commands here, so you can refer this as well. So what are Docker volumes? So when you create a container, they are immutable, and when you stop the container, it dies. So any data which you have stored inside the container dies also. So for example, let's say you have MySQL container running. So it is a database, right? And when you run a database and stop it, you assume that your data will be persisted. But in this case, in case of containers, when you create a MySQL container, store your data and stop the container, it won't save your data. Then what's the point of using containers? So that is where the volume comes. So Docker volumes are, let's say I'll show you using this. So let's say there is a MySQL container, and when I create a MySQL container, I also create a volume, which is small part here, which is referencing to my host OS system. So now this volume is inside the container, which stores the data of the container, but it is somewhere inside my host machine. So if I stop this container and rerun this container, I have like this file in my host machine, right? So I can like get the data again, and like that's how MySQL works. So for example, this is a MySQL image, and if I open any Docker file, so this is a Docker file for MySQL. So if I go at the bottom, then it is like mentioned here, volume var lib MySQL. So what it is doing is it is creating a volume at the var lib MySQL path inside the container, and that volume will be attached somewhere in my host OS system. So let me show you that. Okay, so I'll fire this command, docker run -d MySQL. The name argument is for naming the container. So if you write --name, then it will name it as MySQL and not some random name. then -p port mapping the port 3306 to 3306. -e is for environment variables. So when you run MySQL, then you need to specify a password, or you can keep it empty. So I'm keeping it empty. And if I do this, then it will pull the MySQL image from Docker Hub. So the first time is always, it will take time because there is no MySQL image on my local machine. But if I do it again, then it will do it quickly because of caching. So now if I write docker ps, then it is running a MySQL container. So if I write docker volume ls, then now I have a volume inside my local machine, and the name is this thing. So what Docker has done is, like, it has created a volume which is this. So if I do docker stop, to stop a container, you write docker stop 7773, then it will stop that container. So it won't have MySQL again. But if I write docker run, I'll just remove the name because the container name should be unique. So it has created a new container. And if I write docker volume ls, then there is a new volume. So like right now I had a MySQL container. If I stop it, I just made a new container, that's why it has created a new volume. But you can do docker stop 8AE. I'm stopping the container. So I think there is a command called docker restart, and let's get the name 773. If I do docker ps, then so like by definition, when you stop a container, it should remove all the data present inside the container and stop it. And when you rerun it, it will start as a fresh. But in terms of database, it doesn't work that way. If you are running a database on a container, then it should be able to persist the data. So you use docker volume to store the data inside the container and referencing it to somewhere in my file system, and that way you persist the data inside the container. So any doubt in this?
But data persistence happens in the local machine, right? Not in the container name.
Yeah.
So every time we create an image for the system, there is a new data.
New volume?
created.
Yes.
Shouldn't that data, can we delete that data later?
Yes, you can. You can delete the volume. So like if you have docker volume help, so these are the commands. So the prune command is used to delete the volume. But like if you so like without volume, there won't be a use case of using MySQL or any database, or any use case where you might need to save some. For example, the real scenario will be like, let's say I have microservice architecture, right? So when you deploy an application, so you are running on containers. So you always write logs, error logs, info logs of your application, right? To debug it, or in case of error, it should be like present. So even if your container stops, your log should be there. So that's where you use volume to store the logs on your machine, not inside the container, so that when container dies, you can go through the logs and fix the error. So this is the use case of docker volume if it is not database. So any question in this?
What will be the amount of volume that will be created every time in the
Sorry, won't be?
What will be the volume of the space that will be created?
It is like as it will grow as you use. So just like your file system, it is the same.
Does it depend on the what if there is no hard disk space in the system, or
If you are running Docker, then you should have a storage, right? Because your containers will be also running on your hard disk. Okay, so next is bind mount. So you see there is one arrow here, which means like whatever you store inside the volume, in the container will be stored in the file OS system. Now second is bind mount. So what is bind mount? So it has two-way communication here. Yeah.
Let's say I'm using the volume which is in my local.
Hmm.
When I make some changes, as you said, for the log, it will be local to my local system. And if another person takes the same image, he will not get that data, right? The data
So like they can get the data if they attach the volume to that container. So volume are like, let's say network, you can connect a volume to a container, but you can, I think, connect only one container to a volume, not multiple. So so like for example, another option will be like, let's say I'm running on MySQL server on version 8, but now new version is coming, 8.2. So what do? So you just change the base image to 8.2 and keep the volume same. So now your version is upgraded. So that way it does. Okay, so next concept is bind mount. So see the arrow, two-way arrow. So let's say you have created a container and you have folder lib. So and you also have folder files in your host machine. So what bind mount does is like it references to this folder. So whatever you change in files folder will be like changed in this, and whatever you change in lib folder will be changed in the files folder. So basically they are referencing to same path. And this is what I think you have to use in your assignment. You have to use bind mount, something like that. So when you use bind mount, you can change the files two-way from your host and from the like container. So there are some use case of that as well. Like for logs, I think that this would also make sense, but it has more CPU overhead, but it's like behind the scene. But this is also a use case. I think volumes are mainly used for database, and for logs you can use bind mount because it is more efficient for you to get the logs and all.
We won't be able to tamper with data in the first place.
No. Because it is, I think it will be in binary, not even readable form. So you'll have to access it from the container, like going inside the container and then something like that. I have never tried to tamper it, but I think that would be like the way.
Which is right.
Sorry?
Which one is better?
Depends on use case. Yeah. So like for logs, I think bind mount will be better because you don't have to go to container to get the logs. You can just get it from your system. So like for logs, this one, but volumes can't be like created using bind mounts. It will be only done using the Docker volume. So depends on the use case. So any doubt? Okay, so we can do a hands-on this. So let's say I have this command. I'll just copy this and paste this here. I'll explain what it does. Okay, so Docker container run. This is optional, so you can just write Docker run. You don't have to write Docker container. So Docker run -d -p8080. So this is the same which we write when we run an Nginx server, but now this is new -v pwd. I'll just show you here. So this part is new in the command. So okay, so what is it? So when you want to bind mount some path in your machine to the container, you write -v or -mount, whatever you can write. So it's up to you. So -v, then source path colon path inside the container. So I'm referencing mount folder to this. So let's create a folder name as mount folder, and I'll create an index.html file here. I'll just copy this. Okay, so what I have done is I have created a folder, mount folder, and I have created a index.html file inside it. Now let's go back to the commands. So this thing will give me a absolute path up to this folder lab2, and then slash mount folder, this folder. So I am referencing this folder to user share nginx, this folder inside my container. So let's say this is mount file. So I am referencing this folder to nginx src nginx folder inside my container. So I'm doing this. So let me run this. Before that, I'll just stop all other containers because they are not needed right now. So okay, so I'll run this, and it has created a new container. So if I hit docker ps, then right now one nginx server is running, and if I open this, then it is giving me welcome to nginx, which it shouldn't. Just a sec. Okay, so one container is running. So if I do docker exec-it, paste the container ID and bash, then I'm going inside the container. Now I want to go inside this path. So it should have a index.html. Let's write one. I hope it has nano. Okay. Sorry.
I think you're in
It doesn't matter. Folder doesn't matter, because when you have you can access the container anywhere in your file structure, so it doesn't matter. Mount folder. Let's do it again. Also, in Mac, you might face some error with the bind mount, because of Mac is not able. It doesn't let you share some folders with Docker due to some security concerns. So if you have Windows, then won't be an issue. But for Mac, if you face any issue, then you'll have to use Stack Overflow or something like that. Because if I had Windows here, then I would have easily run it, but right now it's not working. Let me try on play with Docker. So if you don't know play with Docker, it is like a playground which is free for you to use, and Docker is already installed in it. So you just like start using the Docker. So it is a Linux machine somewhere. You can use Docker to learn something. So let me create a same thing which we did right now. Mount folder. I'm creating index.html. Okay, so I have created an index.html file, this one. So I'm now running the nginx command here. So again, I have created a mount folder inside it manually and stored the like index.html file. So if I do this, then it is giving me, this is a custom file in my container, which is like inside the mount folder. So if I write, so I'm editing it. So like, let's say this is my like file system. I'm not inside the container. So let's say, let me add a header. And if I, not this, if I copy like refresh the page, then it is high there. So I have not went inside the container and changed the file. It is in the local machine and I have changed. So that's what it does. Like you have two-way communication with the file changes. So if I go inside the container and change something here, then also it will like show me the changes. And if I am changing in my local machine, then also it will show me the changes. So that's what bind mount does. So this was it. So any question for you? Okay, so let me just stop the recording.